Okay, so we are live. Hello, everybody, in person and remote. So let me give that to you, Doreen. And I think you should be able to click it back and forth now. Yeah, perfect. Is this okay for the size? People, anyone watching either on Twitter or Twitch or YouTube or wherever you may be, please do let us know in the comments if for any reason you cannot hear or see us, and we will rectify that as quickly as possible. There's a small delay. Okay, sorry, that was exactly what I was referring to, that we have some issues, but we are figuring them out as we go. So yeah, please let us know in the comments if anything changes and you can't see or hear our speakers. Okay, Doreen.
All right. Thanks everyone for being here online and in person. This is a PyLadies event hosted by Ecosia. Thank you very much. The food is very delicious. And you will hear more about them in a bit later. I'm first going to do community announcements and introduction of the PyLadies, so tell you what we are, what we do, why we're doing this. Then we're going to have a quick sponsor introduction from Ecosia. And then we're going to have 3 talks in a row. The first one by Paloma, dealing with breaking the code of conduct as a community, lessons learned. So that's also, I think, pretty relevant for us as the PyLadies. And then by Jody, vectorize all the things, how basic linear algebra can speed up your data science code. And last but not least, by Jessica, Python Namibia, our journey of diversity and inclusion. And you already have some food, and you can just grab it as you come in, or whenever you want to get up and get more of it, or just afterwards. And then we're going to make sure we have lots of time for networking afterwards. So, who are we? Great. It worked a second ago, I swear.
Always, it's because I clicked off. It was my fault. There we go.
No, thank you. Sorry. So, PyLadies. Who are we? We're a community around the world of women and non-binary people coding in Python mainly. So we want to support marginalized groups around the world and kind of build a community and be stronger together. And so this is our group, and all skills are welcome, so you don't have to be a pro to come to our events. A lot of the talks are also beginner friendly, and we're happy to have you here. Our mission is to promote, educate, and advance a diverse Python community around the world. And it's great that you're all here. This seems a bit more diverse than some meetups. And we also aim to provide friendly support for a network for gender minorities and a bridge to the larger Python world. And so we were founded in 2013, so we're a bit older already, or PyLadies Berlin. Around 2,307 members, roughly. always write us. Also, we have feedback forms over there, so it can also be very anonymous. So for us, it's important to have a respectful, harassment-free community for everyone, and we do not tolerate any harassment in any form in any of the events or anywhere online. You have to click back. Because we are also quite a bit online. So we have a big Slack channel. Go and join the Slack channel. That's pretty cool. You just go on the website and accept the invitation, and you can go to the channels of your choice. There are many. And as I said, we have a feedback form. It is printed out over there. You can also fill it out online, whatever you prefer. And up for our post. Are we good?
Okay, so good evening, everybody.
Sorry, one
I just got to get there. I don't know why this connection on my laptop is not working. But there we go.
Okay. Go ahead. Yes.
Yes, so once again, hello and welcome, everyone. Welcome to this meetup on Ecosia premises. I'm Sabine, and I would like to give you a quick intro on Ecosia tonight. And I'm a recruiter here, so also if you want to chat about Ecosia or opportunities here, you can always approach me later on, or come to Jessica, Martin. Yes, and also hi everybody who's online. Yes, so let's see. I think the clicker wasn't working,
Yeah.
right?
Sorry. Yeah. There you go.
Beautiful. So a little about us. We are a tech company, also, of course, a green search engine and a B Corp. We earn money through advertising on our search engine results pages, and we use 100% of our profits then for the planet. Through our work, through the work of our product, operations, tree team, marketing, we work to power the regeneration and enable people to be climate active every day. To introduce you to a little bit to our biggest moments, we were founded almost 13 years ago. Tomorrow is coincidentally our birthday. In 2014, we became Germany's first B Corp, and 5 years later, also became CO2 neutral, and we are now 200% regenerative. 6 months later or so, we also became steward-owned, which just ensures that the company's profits will be used to combat deforestation for generations to come. And the company can never be sold, and the control of it will always remain with the people directly involved with its mission, and operations. Yes, and then just around 6 months ago, we reached our 150 million trees, which was an awesome achievement. A bit about our mission. So, as a humanity is finally paying more attention to the climate crisis, it's important to keep in mind that it is not enough to remain neutral or to just offset. Forests, communities, and the planet. It again stopped working.
Yeah, sorry, it's just the connections.
Of course. So a little bit more about what we stand for. You already saw that we invest 100% of our profits for the planet. We're also privacy friendly and radically transparent, because Ecosia is really interested in trees, not your data. We are one of the world's most privacy friendly search engines. We're also publishing our monthly financial reports online, so you can always see them. You can see regular updates from the field on our socials, especially YouTube. And we're beyond neutral, because neutral is not enough. We need to give more back than we take. And that's exactly what we're trying to do, to regenerate. So yes, we have a bit more than 20 million users right now. We are planting in around, I think by now it's around 70 plus locations in 35 plus countries. And we only plant native species. We make sure that those are local species and not invasive. And this is yeah, just the surface of the work, but yeah, so far we've planted more than 160 million and counting. There's a notice here. Okay, so quickly about the roles we're hiring for. I think at least one or two could be relevant to you or your networks. So we're hiring senior data analysts, as well as soon in the future, a full stack engineer. Yeah, you can always approach me or anybody else here from Ecosia and just get in touch. So I'm really happy to welcome you here. I hope you enjoy the talks and the evening, and thanks a lot for your time. I'll welcome Paloma to the stage.
Waiting.
Okay, so now I've added you to the screen. So you are live and you can see your slides okay?
I can.
You want to check this one?
I do.
Hear and see? Perfect. All right,
Thanks.
there we go.
We got it.
thank you everyone who's online. Thank you everyone who's here. I must confess that I do join. I appreciate a lot having the in-person events. And well, this is really a fast talk. I think we should actually have a PyLadies just to talk about that. And that came from a little bit of experience that us as a PyLadies Berlin organizers had. And we wish to give back to other communities so you can have some tools to do in case of that happen, that we wish could never happen. And that is because I think, you know, like when you fly and you have those cards, and everyone has seen that so many times, but how many of you had actually read every single card and had read every single code of conduct of all the events and projects you're part of? Just to share, we have a total of 0 hands showed up. And yeah, no one reads it, right? It became so common, we take for granted what is reading and why is it there? I just would like to mention, because researching where this comes from, I found out Caroline Ada is the person that pushed the project forward, and that's why we have so much acceptance. And I haven't heard her name so much, so I like to bring that up. But basically, forget the idea. What a code of conduct is that place that we wish to be just like an IKEA manual. It's so easy to get and done. No issues, right? We want this to be a tool to deal and to make our community to feel safe and for us to have no issues and, well, to have a safe space that everyone wishes. But the thing is that what happened when it is like this fake IKEA manual that the pieces are not kind of tied together, or when, because we're dealing with humans and all screws or pieces of wood, what do we do when those things doesn't match that well? So a little bit about me, as I didn't present myself in the beginning. I am a developer advocate for FOSS Labs. I'm also a PyLadies Berlin co-organizer, and eventually I'm also a mentor at FrauenLoop, a school for women here in Berlin. Not current, because I'm currently dealing with our own fellowship program, but that's me. I'm also a cat mom. For others, we share that. That's not George, but it's there. But I'm very active in promoting lots of diversity in technology spaces and a lot of more than open source, the FOSS of free and open source philosophy. That's much about me. Going back to the idea. So one of the things that, if we go back to the first idea of the first code of conduct or the code covenant, this is what it says. As a leaders, and that's from I'm changing from the people in the community to the organizer point of view, you are responsible for the safe, fair, and transparent enforcement of your communities. And as an organizer, that kind of freaks me out, because I'm like, just a developer advocate, which kind of tools do I have to enforce something to someone? Me 1.5 meters, literally. And how can it is beautiful, the words. I want that to be safe, but how do I actually do that? And when something goes wrong, how can I do, right? So how can I go beyond the words that it's written, that they are quite nice, to make it true? Because deep down, we actually believe in the humans around us, and we really want to believe in those humans, and we don't want that to break. So we do that, and we make sure to choose the right words, because we believe the humans. But the words are written, and we should pay more attention in which kind of words we are writing. So here follows, in a fast-paced review about some tips that we gather from when that happened, what you should do or how we advise you to do. And the first thing is never put yourself as a target. Most of the time, just like PyLadies Berlin, we have someone that step up and organize some events, and that person becomes the target if the event happened into an in-person event. Avoid that, because we often have the tendency to feel this responsibility written in the code and feel like we want to act upon, but that will make you a target. Instead, you should remember you are part of a community, you're serving a community, and you should also rely on this community to help you make those decisions. So step back, take it seriously, but don't do it as a superhero. I do watch too many superhero series. The second one is try to have a clear process, just like the IKEA manual. When people know what they are dealing with and what's going to happen, it's ideally, I will contradict myself on that one in a few. And I do like this guideline from Mozilla. It does shows the flow chart. If this happened, that's going to happen. That's the ideal situation. But I will contradict myself because I will bring another approach that we had the pleasure to have a conversation with a researcher called Elliot Valley that it's growing on us. But thinking about the humans first, having those processes in place will make it easier for you as an organizer and for you as a community, someone that felt harm, to how to search for help. Even that, something happened, please contact the organizers or the team in general, something that it's make it clear how to act upon. Third one, build it together. And probably that's one of the next steps, or if you have the chance to have a community that gathers together, I would advise that highly, that you try to build this code together using the languages your community uses. It changes a lot from community to community, and using language that people who are part of really understands, slangs or some personal things that it makes people will feel like they belong, and they also need to make this code something that everyone safeguards, not just the organizer. It's a nice tip I think we should try as much as possible. And the fourth one, it's you should not have all the answers. We're all doing our best, but we should seek for help and look for this help into other people with more experience. Sometimes you have a friend that is a good psychologist, or who was also a community organizer, had some more experiences, or even like your boss. Sometimes managers do have some resources on dealing with humans that it can help you deal with some situation. And reading my notes to see if I forget something important. And yes, and just one other thing, when you're searching for this person, try to respect the anonymity, both from the person who felt harmed and from the people that did the harm. And that is quite important, because it is also how we will keep this safe space. So we can bring the stories, but avoiding giving details, or people may feel they are being, not sure about the best word for that, but like they feel they are the target. They can invert the situation in a way that they, instead of feel the one that felt harm and they will be held accountable upon, they will feel the opposite. And this can escalate pretty badly and pretty bad. So yes, I heard, and I can share later with you, at a KubeCon this year, a lawyer talking about a gigantic problem that escalated immensely at DEF CON this year. And this is the first tip that she gave, and I researched for this talk, I believe it was recorded: de-escalate, try to always de-escalate. And this is what bringing to the community does. And respecting anonymity. And the fifth one, and this is the one I will contradict myself into having a manual how to solve, is taking back this idea of punishment and cancellation and looking for resources on restorative justice. And this was brought to us by Elliot Valley. No meaning someone expert on that, but I've been reading a lot. And he has been teaching us a lot, especially how to push back from this idea of we will punish or we will cancel or we will feel harm. And this is like the tips in like a checklist. But this is like in a very fast pace also understanding what it is about. Is you involve everyone and everyone is part of the problem and of the solution as well. It is deal not with you're the guilty, you're out, but we understand as a systemic issue that we all should take care of it. And take care meaning be held accountable and bringing solutions. On the top of it, it's always the idea that the victim will have a voice. And this is super important for healing. But most of all, we avoid further actions or further harms. And this is just a quick example when you do like a traditional punishment justice, when you go for like what has been broken? You push back and say, wait, which kind of harm has been done? And who broke it, like a pointing the finger to what are the needs for those to be involved. I mean, who can be part of it that can help us understand the system around it? And instead of which punishment, how can we have this harm repair? And it has been used a lot in schools, and this is a great example in schools when you have like a zero tolerance policy, you ended up creating someone that will have anger and probably pursue a career in crime. And in the other part, you have someone that learn and a community that learn together. And that's it, because 10 minutes is pretty fast, but I left a lot of resources to take. Those are my personal ones that I like, and those are Elliot's resources, and the first ones are a bunch of nice, cool, fast videos. Thank you, everyone.
Thank you, Paloma. We won't do questions now because we're going to go through all of the talks. But if you do have some questions, how can folks reach out to you?
I
assume if they're here in person, they can reach out to you in person.
I'm here. You can send me an email, paloma.oliveira@fosslabs.com. Mastodon, I didn't update it, but I'm still in tweeting. Sadly, it's P cultural. You can reach me.
Perfect. Thank you again.
Thank you. Okay.
Okay, and hopefully folks are seeing and hearing us now online. Just double check this is working for Jody, and we will make this a wee bit bigger so that I can still check that. All right, can make those speaker notes a bit bigger. Perfect. Maybe not too big actually. Okay, all right, thank you. Welcome, Jody.
So hi everyone, I think I've met a few of you before. For those of you who haven't met me, I'm the data science developer advocate at JetBrains, as you can see from the slides. Brought some stickers tonight, so please do help yourself. Sorry for those who are not here in person, come next time and I'll bring more stickers. So today or tonight, I'm going to be doing a half an hour talk or so to show you some ways in which vectorized operations in NumPy, in Python, can speed up your data science code. But if you're not a data scientist like me, you may also get something out of this talk. It's more I use data science code as an example because I am a data scientist, but also because I kind of think that data scientists don't tend to be as confident programmers as engineers. And for me, this was a bit of something that really helped me a lot. So something that I kind of want to share from that perspective. Okay, so if you're anything like me, when you first learned to program, my first programming language was Python, you thought loops were the best thing ever, bread and butter. And a lesson I quickly learned is that when you hit any kind of scale, particularly when you're working over huge amounts of data, loops get really slow, really fast. And you know, I knew I could optimize this code. I knew it was inefficient, but I didn't really understand how. And I was reading around and I saw, you know, you could use these NumPy operations. I just didn't really get it. And I completed a linear algebra course a couple of years ago, and everything kind of finally clicked. So what I want to do is explain these NumPy vectorized operations from the perspective of the linear algebra behind them. It's not going to be a deeply mathematical talk, but it'll just give you enough of a background to kind of get that perspective that kind of helped everything click for me. So what I'm going to do is give an overview of a few different ways you can use these vectorized operations to speed up your code. And what we're going to do is iteratively improve an algorithm called k-nearest neighbors. So I chose this algorithm because it's based on pairwise operations, and that tends to involve using a lot of loops. So this tends to be like the sort of algorithm that if you're coding it by hand using loops would cause you massive processing bottlenecks. So what we're going to do is we're going to start by going over some basics of linear algebra, and then we're going to quickly go through how k-nearest neighbors works. We're then going to start with this really inefficient, unoptimized implementation of KNN, and it's going to use a lot of loops and lists, and then we're going to see how long that takes to run. For the remainder of the talk, we're then going to go through 3 different iterations of improving this implementation of the algorithm, and at each stage what we're going to do is take out some sort of inefficient piece of code and replace it with a vectorized operation that will make it more efficient. So let's start from the beginning with some linear algebra. So the most basic unit in linear algebra is a vector. So for the purposes of our talk, vectors are basically ordered sequences. And if we relate this back to the data that you use in machine learning or data science, you can basically think of a vector as a row in a table. So you can see here, in these vectors, the first value is the first value in this table, and the second value is the second value in this table, and each of these vectors corresponds with a row. So what do the vectors represent in terms of linear algebra? So we can think of vectors, they're more than this, but for the purposes of this talk, for all we really need to understand, they're coordinates in an n-dimensional vector space. So breaking this down a bit, all the vector space is basically the coordinates of particular points in n dimensions. So a scatter plot is a two-dimensional vector space because we have one dimension here and another dimension here. And what you can see easily is that each of those vectors corresponds to coordinates in that vector space relating to their values on the first and the second values. So I'm going to be using a data set which has 16 feature columns in total, and you can represent each of the rows in that data set as a 16-dimension vector which lives in a 16-dimensional vector space. And we obviously can't visualize that. This is why I stuck with 2 dimensions. But what I want to illustrate is that anything that you can imagine in 2 dimensions in terms of linear algebra can be generalized out to any number of dimensions. And this is a really important point that you'll see when we come to looking at k-nearest neighbors. So now that we've covered vectors, matrices are pretty easy to understand. They're simply a collection of vectors that live in the same vector space. So these are our 3 ones that live in the 2-dimensional vector space with those 2 features that I talked about earlier. And if we go back to the data set sort of analogy, what you can see is essentially matrices are equivalent to data frames. So NumPy represents vectors and matrices in what's called an array. Arrays unfortunately have their own concept of dimension, which is a little bit different from what we just talked about. In NumPy, what a dimension is the number of sides in which an array can change size. So I'll explain this a little bit. So vectors are unsurprisingly represented in one-dimensional arrays. So that's because they only ever change size in the number of elements that they have. They never change size in this, because this represents the number of vectors. There's only ever one. And arrays also have this quality called shape. You're probably familiar with this if you've used NumPy. Basically, the shape describes each of the dimensions. So we've only got one dimension here, and their size. So unsurprisingly, again, matrices are represented as 2-dimensional arrays, and that's because they can have a number of elements in each vector, and also the count of vectors that live in the matrix. And then handily, NumPy has this concept called n-dimensional arrays. They can be 3-dimensional arrays, 4-dimensional arrays, and higher. And essentially what they are is a reshaping of 1- and 2-dimensional arrays so that they sit in a higher dimensional space. So what you can see is here, I've reshaped that 2-dimensional matrix, the 2-dimensional array, into a 3-dimensional array. And what this 1 now represents is the number of copies of the matrix. This is the way that I think of it. It gets a little bit more complicated as you get into 4 dimensions, but here we can still imagine it. And what we've got here is then the number of vectors and the number of elements in each vector. So let's now briefly go over how k-nearest neighbors works. So it seems very obvious, but a very useful property of vector spaces is that the closer points are together to each other, the more similar they are, and the more far away they are from each other, the more dissimilar they are. So you can see that here with the beams, these points, or sorry, the data set is about beams. I didn't mention that earlier. So if I'm talking about the beams, that's what the data points are. It's not really important, but just to clarify. So we've got the beams here, which are of the same type. They're the same color. So those that are of the same type tend to be close to each other. Those that are of different types tend to be far away from each other. So there are lots of different ways of measuring distance in vector spaces. I'm going to be using one of the simplest ones, which is the Manhattan distance. So to measure the Manhattan distance, or to understand it, imagine that we're in a 2-dimensional vector space. And we want to get from this point here, B, up to this point, A. So when we're using the Manhattan distance, let's imagine, this is the easiest way I find to think about it, we're constrained to only going along the x and the y axes. So we take a little walk from B, so boop, boop, 2 spaces, and then take a walk up y, another 2 spaces. And that gives us a total Manhattan distance of 4. And we can also do that computationally by subtracting each element of the vector from each other. And what we end up with is, again, that calculation of 4. So we can generalize that into a Manhattan distance formula. And what we end up with is the sum of the absolute differences of every single element of the vector. So this would be the subtraction of the first element, the second element, all the way up to the nth element. And again, we're coming back to that idea that this could be 16, this could be 32, this could be 100. you're not constrained to 2 dimensions. It can be as many elements as you want in that vector. And finally, let's get to how k-nearest neighbors works. So we start with a data set. Unsurprisingly, this is data science. And what we do is we take the data set and we split it into test and train, 2 different data sets. So then we take every single data set, every single point, sorry, in the test data set, and we measure its pairwise distance to every single point in the train set. So you can see this is already getting to be a very expensive operation. Then what we do is we restrict it to the k closest points, hence k nearest neighbors. It's usually a small number between like 3 and 10. It's a bit of a, you know, who knows, guess and see. And then what we do is we get the labels of those k nearest neighbors, and we just find the most frequent one. And that becomes the label that we assign to that test point. We then repeat this for every single test observation. So I think you're already starting to see where it's going to get expensive. So we've covered all the theory. Let's get into the code. Well, actually, I haven't covered all the theory. There's a little bit more, but we'll break it up with some code. So let's go through an example of how we might implement this using loops and lists. And let's jump over to the Python code. So I'm going to be presenting a series of functions. The first function is to calculate the Manhattan distance between 2 vectors. So what we do is we take in the first vector and the second vector represented as a list. And what we do is, is we loop over every single element in that list and we subtract them pairwise. And then we just do a sum at the end. So this is the important bit here. What we then do is we apply this Manhattan distance function pairwise to every combination of test and train points. So what we're doing is we're passing in all of the train points and all of the test points as lists of lists. We then have this nasty little nested for loop where we calculate every single permutation of the distance between every test point and every train point. We then calculate the most likely label for a single test observation based on the closest training observations. So what we do is we take in, for a single test point, every distance to every train point, the labels of the train point, we zip them into a list of tuples, and then what we do is we basically, then we sort them and get the closest. And then we basically extract the labels using this list comprehension. And then finally, we use this function to apply it to every single test point. So we've completed our first implementation. Let's now test it. And I'm just going to show you how I'm going to test this. So what I've done is I've extracted 3 different samples from my main data set. I have a small data set that has 3 features, and it has about 4,000 observations. I then have a medium data set, which has those same 3 features, but it has all of the observations, so around 27,000. And then I have a large data set, which is just the main data set. It's the whole thing, has 16 features, and it has every single one of the observations. And the reason I've done this is I want to see the effect of 2 different things. I want to see the effect of increasing the number of features and increasing the number of observations on the efficiency of the algorithm. So let's see how we went. So on the smallest data set, still took 15 seconds. That's pretty bad. On the medium data set, we've jumped up to 12 minutes. And on the large data set, we're at an eye-watering 40 minutes to calculate this. And yes, I did sit here and calculate all of these. It was an exercise in patience. So the main difference in the time that it takes to run k-nearest neighbors over the medium and the large data sets is that thing I mentioned, basically the number of features. The medium data set and the large data set have the same number of observations, but the medium data set only has 3 features, where the large data set has 16. And the culprit is this guy. Basically what we're doing is we're sequentially looping over every single element in that list and taking the difference. So we're going to work out how to vectorize this, and I'm going to give you a little bit more theory to do that first. So it's possible to do a number of arithmetic operations on vectors and matrices. So these include addition, subtraction, and multiplication. Obviously for us, it's really useful that we can do subtraction. So it's really easy to do. Basically, you just need two vectors or matrices of the same size, all of the elements line up, and you get a vector or matrix containing the differences. Really straightforward. You can also do operations on every element of a vector. Basically, what you're doing is you're passing a vector or matrix into a function, and that function gets applied to every single element. So the most famous of these is scalar multiplication. It's basically where you multiply every single element by a constant number, just a fancy term for that. But, you know, for us, it's very useful. We can do things like take the absolute value. So you can see how that works. You just get a vector or matrix of the same size with that function applied to every element. So that's all the theory we need to do the next transformation. So what we've done is we've basically converted our first function in a way that we can calculate those differences between every single element of the vectors using a vectorized operation. So instead of inputting vector A and vector B as lists, we're now inputting them as NumPy arrays. And what that means is that nasty loop is now replaced by this beautiful notation, basically very readable, and then we can then apply that vectorized absolute value function over it. So let's see how this went. So we're now down to 8 seconds for the smallest data set. We're down to 7 minutes for the medium data set, and we're down to an impressive 9 minutes for the largest data set. So if we take this as a sort of function of the baseline, we're at about 1.8 times more efficient for the smaller data sets, but for the large data set, we're 4 times faster. So we managed to make some good gains already, but we haven't made as much of a dent in the computational time for the smaller data sets. And the main culprit is that nested for loop that I pointed out earlier was going to be a problem, you know, foreshadowing. So once we start nesting for loops, it becomes a problem because the number of operations that we need to calculate sequentially scales as a function of the product of the number of elements in each list. So we basically need to multiply the size of the first list by the size of the second list and then calculate each of those sequentially. So even in our teeny tiny small data set, we're doing 3 million sequential operations. In the medium and large data sets, we're up to 140 million sequential operations. And these are tiny data sets, like by machine learning standards. So once you start building up to scale, this is why I was getting problems in the past. It's just not scalable. So what we're obviously going to do is get rid of this nasty guy. And in order to do that, let's just jump into a little bit more theory. So to start, let's imagine that we have only 3 vectors, x, y, and z, and we want to find the pairwise differences between each of them. So this is what we've been doing with that nested for loop so far. Let's start with getting the difference between each vector and the x vector. So one way we can do this more efficiently is instead of calculating these differences one by one, we can create a matrix which contains x, y, and z. And what we can then do is create another matrix which contains 3 copies of x. Because they're the same size, we can just do a straight vector subtraction. The problem is we still need to repeat this exercise for y and z. So we're going to have to loop, right? Well, we would if we were restricted to using 2D arrays. But remember, we can use 3, 4, 5-dimensional arrays. So let's have a look at how this would work. So let's take our first matrix. This is a little bit dense, but stay with me. We'll take our first matrix as a 2D array, that one that contains 1 copy of each x, y, and z. We then reshape it into a 3-dimensional array. And then what we do is we replicate it so that we have 3 copies side by side. So now we have a 3 by 3 by 4-dimensional array. We repeat the same exercise in a similar way. So we now have that matrix that contains 3 copies of the x vector. We then create a similar one for the y vector and the z vector, squash them together, and we end up with a 3D array of the same size. Now they're the same size, so we can basically line them up element-wise, do a nice subtraction, and voila, we do it all in one pass. But the problem is, we've explicitly replicated our vectors multiple times, and this is really inefficient. And again, we're only talking about 3 vectors here. Once we start scaling, not so good for memory. So NumPy has another trick to help us here, which is called broadcasting. I'm sure a lot of you have heard of it. This is essentially a memory efficient way for NumPy to do the sort of operation that we just did without the need to explicitly replicate the vectors within the arrays. So the way that it works is, if we want to do an operation with two arrays, NumPy will first compare them and check if they have the same number of dimensions. If so, it will then check whether the arrays have the same size in all dimensions. If it does, then great, the operation just is carried out directly, like in the previous slide. But if not, it then checks whether one of the arrays has a size of 1 for that particular dimension. And if that's the case, it then replicates along that dimension until it's the same size as the dimension in the other array. I'm going to show you with pictures. It's a little bit gnarly, so it's easy to understand with diagrams. So to start, we take our original 2D array containing one copy of X, Y, and Z. Up here, what we do is we reshape it. So we have one copy of that matrix sitting in the first dimension. What we then do in the second step is we reshape it. So we have one copy of that matrix sitting in the second dimension. What happens when we then go to do the subtraction is that NumPy will compare them compare on each dimension, and it'll see it has the same number of elements in the last dimension, but here it has a size of 1, and here it has a size of 1. So it knows that up the top here it needs to stretch along the first dimension, and here it needs to stretch along the second dimension. And what you end up with as the product, the consequence of this calculation, is a 3 by 3 by 4 matrix array containing all of those differences. So the same one that we did by explicit replication, it just does it implicitly. So let's see how we will do this in our code. So what I've done here is I've actually gotten rid of that first function where I was calculating the difference between each vector one by one. And what we're doing is we're doing everything in one pass. So what we're doing is we pass in all of our train and our test observations as two-dimensional NumPy arrays. And here is the step where we do our subtraction. So what we're doing here is that reshaping I was talking about. So we use this slicing notation. Where we set a value of none, we're asking NumPy to assign a dimension of 1. Where we use the colon notation, we're asking it to keep the original size. So what you can see is 1 in the first dimension, 1 in the second dimension. Broadcasting is done. We then have a 3D array. We apply the absolute value function and then basically sum. So it's all done in one pass. So let's see how it improved our computational efficiency. Now we're down to 1.5 seconds for the small data set, 1 minute for the medium data set, and 3 minutes for the large data set. So we're now between 10 to 13 times more efficient. There's still one final thing we can do. We haven't touched any of the code to do with calculating the nearest neighbors. So the most expensive operation that we have here, I pointed it out before, is the sorting operation. Then we also have this operation here, where we've essentially done a loop in order just to extract labels. So this is not a very efficient piece of code. So let's see what we can do a bit better. So the first thing is that sorting is actually done slightly differently over lists versus NumPy arrays. So sorting in lists is locked to one sorting algorithm, timsort. And in contrast, NumPy's two sorting methods, sort and argsort, have a bit more flexibility. So firstly, you can specify whether you want stable sorting or not. If you say you don't want stable sorting, it will default to quicksort, which is much faster than timsort. And even when stable sorting is selected, the algorithm does adjust to the data type of the array. Because remember, one of the differences between arrays and lists is arrays must have the same data type. So the other issue is this list comprehension I was talking about, where we're looping over that list of tuples just to extract a label. And so that's a for loop in disguise. So let's see what we can do a bit better. So the magic is happening in this line, but I'll explain how we get there first. What we take in is the distances and the labels as NumPy arrays, and we zip them together to make a 2D array. What we then do is we sort this 2D array on the distances. We take the top k, and then we use this nice slicing notation, which means that we essentially say, I have a matrix, give me just one column of it. Don't loop, just slice it and separate it out. And that essentially is the line that is replacing all of that inefficient code. So our final times, we're down to 13 milliseconds on the small data set, 15 seconds on the large data set, and 2.5 minutes on the large data set. I really like your chick.
You sound really excited about it.
I was so excited about it. So as you can see, we're 15 times faster on the large data set, 50 times on the medium, and over 1,000 times faster on the small. So I'm happy to chat about why I think it went, more extreme on the small data sets later. But yeah, that's basically it. So thanks very much. I'm on Twitter, Mastodon, and I also have a blog. And thanks very much.
Sure. So if folks have questions, if you're watching online, feel free to put them in the chat. I'm trying to type and speak, which I'm not great at. But if anyone else in the room has a question, if you want to raise your hand and ask it, if you could repeat the question, because we probably will not hear any audio from the rest of the room.
Sure. No questions.
No?
I have a question.
Sure.
Like, how important is it to be able to visualize all of this in your head?
For me, I think. Oh yeah, sorry. Thank you.
I don't know if we will.
I love that I forgot immediately. So the question was, how important is it to be able to visualize all of this in your head? I think for me, it's really important to get my head around the concept. So I think the only reason that this clicked after I did the linear algebra course is because I did this amazing course by this guy called Gilbert Strang, so available online. Yeah, I see some nods. And he is actually very visual in the way that he describes it. So I think once you understand this concept of the vector space being a very geometric thing, it then starts to make a lot more sense about, okay, this is why this works. But I guess other people work in different ways. For me, it's just super important to visualize it. Also, just to tell you my theory about why it's so much faster on the small data set, I think it's because, so when we do the broadcast subtraction, you still need to store that, and you need to store it in a contiguous piece of memory. So I think it's actually the time it takes for the system to find a large enough chunk of memory, shuffle things around. This is my theory. I'm not an engineer, but that's what seems to make sense.
What's the memory consumption? So you said if you do it in NumPy, it doesn't actually occupy all the space, so it just has pointers basically. Or?
I think so. It's not occupying space. Oh, sorry. Yes, thank you. So the question was that basically it's not actually consuming all that memory to do the broadcast operation. The problem is that the product of the broadcast operation still needs to be stored. So it's really interesting. I actually found that at a certain point, I could no longer do this broadcast operation. So the way that k-nearest neighbors is actually done in packages like sklearn, they do approximate nearest neighbors. They don't calculate every single one. And I think it's just simply you cannot efficiently store that many difference calculations. So it's not even the calculation after a certain point. So I love that I get you all excited, and I'm like, actually it breaks after 50,000 rows. But yeah, I think I'd love to do a follow-up talk where I talk about approximate nearest neighbors methods, because it's really interesting.
We would definitely be open to you coming back and doing that talk.
That's really cool.
Great. Okay. Thank you so much again, Jodie. And we will just quickly switch the system again. So if folks need a drink, or if you need to use the bathroom, by the way, it's through this other room here. And Jessica, if you want to head over, we'll set you up. Stop camera. Okay, and we are back on the live stream and we are back in person. So now I would like you to join me in welcoming Jessica. Very excited to have you join us. I know that you've been in Berlin a little while, but you're actually talking about a topic of a community a bit further away. So it's really exciting to have you join us and looking forward to hearing your presentation.
Thank you, thank you. I hope they can see me.
They can see you. Yeah, this is your camera here.
Okay.
And they can hear you.
Okay. Good afternoon, everyone. Thank you so much for coming tonight. I know it's a cold night for me. It's super cold. Thank you for joining me. Today I want to talk a little bit about Python Namibia as a community, and also talk about ways in which we have included diversity and inclusion and equity in our community, whether directly or indirectly. I will also discuss maybe some of the ways that our communities can collaborate to extend this talk to a much bigger discussion. If you want to get in touch with me, that's my email, but that's my name almost across all the platforms, so you can find me everywhere. If you want to follow my community, those are our handles, Twitter handles, our Python conference website, and also our email. Right, so what brought me today is what happened in 2015, a conference that was brought to Namibia by a white man from Cardiff. He wanted to have a conference or to organize a conference in Africa. And at the time when he had this idea, there was already a project that was happening in Namibia. And so through Cardiff University, they collaborated with my local university, University of Namibia, and together they organized the very first Python conference. And so this is how my journey started. And now I'm standing in front of you, so it has been quite a good journey. Thank you. So how it started was that it was a 4-day conference. They had talks and workshops and all this sort of thing. And initially, when I heard about the conference, I heard it the year before, towards the end of the year, and I was not so much interested in it. At this point, I was almost in my final year. I had done Visual Basic, I had done Java, and I knew nothing about programming, even though I passed those modules. So I didn't have any interest in this type of conference. But the following year, the conference was happening early in the year, and I had a lot of time, and I thought, well, there's free food, I can just go there and have free food. It doesn't matter. And so that's how I ended up at the conference. And 4 days later, I was one of the volunteers to keep the conference going. And so over the years, we have continuously organized the conference. You can see its numbers, you can see some of the talks and workshops that we have had over the years. In 2020, we had an online conference, and next year we are bringing it in person in February on the 21st to the 23rd. So if you want to collaborate or you want to have maybe give a workshop or a talk, the call for proposals is open at the moment. So you are free to send us a proposal. Now, let's get into the Python Namibia Society. So this was our first meeting. This is the 4th day. We thought we were the it people. We thought we were going to continue the community. So we were feeling ourselves on this day. This was the first meeting of people that were volunteered at the conference to continue the work of the community. So a little bit about Python Namibia so far. We have come up with several user groups. Some of them are active, some of them not so much. But we have been able to establish at least some of the subgroups, and some of them we are very proud of. And just recently we became partners with the carpentries. We sort of wanted to see if Maybe there were some people that were interested in being taught on some skills on data science and so forth, or being instructors and this type of thing. So we are we just became recently registered as a non-profit, and so we are sort of looking for collaborations and things that we can do to build capacity and things like this. So that's how this started. Initially, myself, I was a workshop organizer for the carpentries, and so I saw an opportunity for membership, and I thought, why not? So we also have a PyLadies group, not super active at the moment, but we do have it. We have finance scholars, which is something that we are very proud of as well, a high school group that we have brought together. Now, in general, Python in Namibia is coming. When we started, it was really a language that even myself was talking bad about, because I thought, why would anyone want to do Python? This was also influenced by my friends, because I didn't know anything about programming in the first place. So I had no place to have an opinion about Python in the first place. So right now, as we speak, we have Python in the 3 major universities in Namibia at different levels of their studies, some of them at master's level, diploma level, and the undergrad. We have seen it happening directly or indirectly through their data science courses and so forth. So it is existing at the moment. In schools, when I started, I was a high school teacher as well after I finished my studies. And so when I was a school teacher at the time, there was no Python really being done by anyone in schools. And still at the moment, high schools in Namibia are free to use any language, any programming language that they want to use for teaching purposes. But what I've seen is that now it's progressively being used a lot more. And how I see that is that we have a programming competition that we have, which is for high school learners. And when we started, my school was the only school that was using Python. But as we speak, almost all the schools code in Python now at the programming competition. So I see that now it's being used a little bit more, and maybe in the future we'll have it more dominantly in the high schools as a main language, for example. Okay, so what are some of the things that we have done to make sure that our community is a diverse community? Some of these things, or I think I can say that it's all of them, because we did most of these things without necessarily knowing about the concept of diversity, equity, and inclusion, or the movement. We did all of it without knowing about the movement, but we did it sort of in a way of trying to solve problems within our own community and seeing where do we see the gap and what can we do to make sure that that gap is filled. So one of the ways that we have done that is through our Pioneer meetup. This was all thanks to the COVID. And so how we do this now, how we do our meetups now is that we do them online, and we make sure that we at least have one speaker from an international community, one speaker from any of the African communities, and we want to make sure that also women are represented during the meetups. And so we kind of now have a structure of being able to include people from outside of Namibia, because now we host it online. Another way that we've been able to do this is through our Python conference. The conference itself is organized by not only Namibians, but also we have international people within our organizing committee. And this is usually intentional, because we don't just want to have our own skills and our own ideas represented, but we also want to have a diverse organizing team. Also because it started that way and we wanted to keep that culture. So every time the conference, for example, finishes, we usually have friends who come from the international community who visit, and most of the times they want to get involved in the community in one way or another. And the conference is one way that we do that. Our ticket prices is also very, very low to accommodate people who cannot afford, because in general in Africa, the economy is quite bad. So we try to make sure that everyone is at least included. We have had low prices that are close to really, like, you are not really paying much. And we have tried to limit free tickets because a lot of people want just free tickets and then they don't show up to the conference. So we have tried to sort of kind of not have free tickets, but we have opened that up to maybe someone, if someone wants to collaborate or maybe to contribute to the conference, but they're not able to make it, for example, they can buy some tickets to accommodate some people who are not able to buy tickets, okay? Yeah, and then usually in our conferences, half, if not more, of the talks and workshops are from international communities, either from the West or within Africa. Initially, when we started, we wanted to make sure that every year we have at least a representative of someone in Africa who is from a community that is not yet established, so that they can come and see how the conference is, to come and see how we simply just organize a small conference, and then maybe that will motivate them to build their own community. And through that, we saw Python Africa being established. So we have consciously tried to build the African community in that manner. And then while I was a teacher, not necessarily while I was a teacher, but initially when we started kind of defining what we wanted to do as a community, we wanted to work with high school learners. One of the things why I was personally passionate about this was because when I went to university, I had an idea that I wanted to do computer science or IT or software engineering. These were terms that I had just from people mentioning them, and I didn't do any research on them, but I knew that they had something to do with computers. And so through that, I decided, okay, I want to do something that has something to do with these three terms. But when I went to university, I didn't know anything about programming. And so it was so difficult and it was just a whole mess. And I finished my degree without really knowing how to code. So I felt like it was my duty to expose learners to computer science either as a career or through coding. And if I have the ability, I should teach them how to code so that even when they come to university, they can make use of the skills or understand it at a deeper depth than I could. And so we made sure that we were going to include high school learners within our efforts to build the community. And through this, we organized what we called Computer Day. So Computer Day was a conference organized for learners, also by learners. So we put our efforts together and we organized a conference that was just for high school learners. It was a 2-day conference, 1 day for workshops and 1 day for talks. And these talks would be specifically me reaching out to developers within the community to specifically talk to them about a possibility of a talk, and also for us to frame it in such a way that it is useful to the learners and it's also comprehensible to the learners. And this was a lot of fun, both for me, it was very satisfying, and also for the learners. But we did not continue it a lot. Also because not everyone is passionate about dealing with children, and they are not always so easy to deal with. So this is something we want to continue, but we don't always have the capacity. So also we have built a Python tutorial. We call it PyTila. One of the scholars came up with this idea. So we usually had like a monthly kind of training where we would invite different schools to come and attend a Python training together. And through this, there was some learners that were really troublesome, in a sense that, I don't know if I can say troublesome, but they were troublesome to my instructors. In a way that they were not understanding the concepts so much, and they kept calling them over and over again. And then this child decided, I need to create a tutorial, very simple, and it needs to be translated into our local languages so that these learners can read these things. Maybe that way they will understand a little bit better. And so that's how we came up with PyTila. And so now we kind of have written the whole structure of the tutorial. We have opened it up for reviews and editing and this type of thing, and eventually we will find a way to translate it into local languages. Right. So now, given this opportunity of us being together in such a diverse room, not all of us are from Germany, for example. We are all from all over the world. I know from your accent you are from Australia, I think. We have South America, we have, I don't know, Asia. So, and we have Africa and also Germany and all these other different backgrounds. I think this is a good opportunity for us to discuss, maybe not only here, but also between emails and video calls and things like this, to see how do we put our efforts together to see what small impact we can do through our communities that are trying to come up. Maybe we can make a difference, right? So for us, one of the things is career opportunities. As a community builder, I have tried to come up with different workshop ideas, different ways I can give back in a way that is fun for me and also maybe not boring to the participants. So I have come up with different formats of workshops and trainings and things like this, but I cannot offer these people jobs. So I feel like and I'm also not yet a proper developer where I've been put in a company and I'm able to develop software. Most of the work I've done is teaching. So I feel like I need people who are actual software developers who are in companies, who can act as mentors to these kids or to these community members, because we don't only teach high school learners, we teach the whole community. Someone maybe has a company and they want to employ some interns to kickstart their careers, or in any possible way of way that you are thinking of that you can help another developer come into development. I will appreciate some ideas on this. Capacity building, I can only teach so much. I don't know many different things. So I feel like maybe collaborating on some workshops or trainings or things like this coming from people who are actually in the industry will really, really help. Volunteers are also very welcome. We are now registered and we now need hands in different aspects, whether temporarily or a little bit long term, it doesn't matter, but we need hands to sort of see how we can build the community at a structural level. Volunteering for projects, mini projects, maybe with the scholars or with community members, maybe a project of 1 month or whatever capacity. I feel like we need some ideas on how you can volunteer. I also mentioned maybe being part of the organizing team for the Python conference. That is also a good way to volunteer. Through partnership and funding, I feel like at this stage, if we really want the organization to move forward, we need to find ways that we can have people that we can even pay to sort of keep the structure of the organization going. I have worked for many years for free, and also including my colleagues, and now they are having children, now they are building their careers. Not everyone has time anymore to do this thing. So maybe at some point, if we really want this to keep going, we need to start putting solid grounds in the organizing structure. If you know of an organization that maybe wants to partner on a specific project, maybe a training program, or maybe being part of the translation, maybe we can have a little bit of funding to pay some people to translate the material, or to, I don't know, do design or edit the whole book. I don't know, anything of that nature is appreciated. If you maybe know of some funds for certain activities, I feel like we can also you can also share some of the information. So what I have done, for example, is I have opened a Patreon account, and we have 10 patrons that have been contributing for a little bit now, but we don't have yet enough funds to build a computer lab. So our idea was that at least every year or every other year, we will build a computer lab at different regions. And so through the Patreon page, we felt like, okay, maybe this is a way for us to accumulate small funds together, and maybe one day we'll be able to say, okay, I built this computer lab here. Next time I'll go to a different region, and maybe at some point we can now have our trainings or workshops in these small central areas in different schools, where we can now have all these trainings and workshops. And that idea we came up with it because at some point we were going to schools to teach coding to the schools, and you come to the school and there's either computers and they have not been updated for many years. You are trying to install Python, none is working. They want maybe 2 point something or 1 point what was. That's the only one that will work. Or there's no internet. They have not had internet for a long time, and so computers are not updated for many years and things like this. So there was a need for us to at least have maybe a central computer lab here and there to try and build those in such a way that maybe at some point we can maybe have a workshop or a training for this region, and then we have a hub where we can meet and things like that. So this is some of the things that we can think about and ponder about and maybe discuss at a later stage. With that, I don't want to take more of your evening. If you have any questions, now is the time. I hope I didn't burden my online community, but yeah, thank you.
Maybe also we can put up the slide with your contact details again. It was the second one, right? Yeah. Sorry, just flashing through. Yeah, that just in case. Yeah. So yeah, amazing talk. Everyone online is saying fantastic. I think everyone here also really enjoyed it. Does anybody have any questions that they would like to ask? Paloma, if you can repeat the question.
Because this is like our main point in PyLadies Berlin is bringing more diversity. How is the diversity ratio for gender, but also age in your community?
So before you answer, repeat the question just because they won't hear that.
Okay. So you're asking what is the ratio of diversity in terms of gender and age? I feel like we have a lot of young people. I don't have the statistics for age, but we have a big amount of youth within our conferences, lots of participants from schools, lots of participants from university, not so much from the industry. I feel like we need more people from the industry, especially the local industry. But gender-wise, our gender is 50-50. There's lots of women and sometimes even more than men, especially at our conference, where we have had the statistics. So we don't have a big problem in terms of attendance of our conference, but there is still more work to be done when it comes to actually continuing the skills after the workshop trainings and things like this to get into an actual coding job, for example, and things like this. But attendance for the conference, for example, where we took the statistics, 50-50 and sometimes even better.
There were many things that you mentioned about like how to improve the community, the things that many other communities can relate. Can you maybe from the top of your head like list the top 3 things that you think that the Namibian community, the Python community needs more?
Repeat the question.
Oh, sorry. Okay, so you want me to mention three ways at the top of my head where you feel like
So
we
contribute
need
to the community,
contribution.
right?
Okay, yeah. I think first thing is career, because we have given them lots of workshops and trainings, and I feel like there has to be the next step. That next step is missing. We want to involve more high school learners, so I feel like that part where we need to really find resources to build computer labs, at least one per year, we need a lot of help on that. Capacity building is also a thing, but equally on that is also building the society at an organizational level. So either you can come in as a volunteer to help build the structure if you are at least skilled at that. I don't know those things. I lead the community, yes, and I use whatever knowledge that I have, yes. But when it comes to like actual business, when it comes to now the organization being registered and this type of thing, I don't know any of that. So that's one way that one can get involved, or maybe teaching, you know, coming up with some ideas of how we can actually build the capacity. I feel like those are really important areas.
Thank you.
So we have maybe a somewhat similar question on the chat, but Mari's asking, what is the biggest challenge of the Python community in Namibia? So
I think the biggest challenge is that we personally, that I meet when I'm trying to teach, is just the resources. I have at least taught myself a little bit to give back. So sometimes I want to go out and go to different schools and teach. The resources are limited. Sometimes I also want to go to different towns and different regions, and I can only do so much from my own pocket. And so sometimes I cannot go much further without those type of resources. So there is a need in that sense. The resources to me is a big problem, and also the jobs now, to say, okay, I have taught these people, but now what is the next step? I feel like, yeah.
I can identify a lot with that. And I think you've alluded to it a bit, but then I guess my question would be, what motivates you to keep doing that, even though you have all these challenges?
I think it's, if I'm not doing it, then who will? You know, and also sometimes I'm like, that brings me joy. That brings me so much joy. If I just go to a high school and we are just, you know, either brainstorming on some ideas, or we are running a workshop together, or those things excite me. That's the fun thing for me. So it's like, no, who will do it if you're not doing it? And it's just fun.
Yeah.
Yeah,
Yeah.
it's fun.
I can tell. Okay, any more questions? Okay, so we will close out now. Thank you to Jessica, thank you to Jody, thank you to Paloma, thank you to Sabina, thank you Doreen for making this event really awesome. Thank you to everyone who came and everyone that's watching online. Online folks, we will say cheers to you and hope you enjoy the rest of your evening or day, depending where you are. Folks that are here, we still have some snacks and some drinks, so feel free to like mingle a little bit and get to know each other a little bit. And yeah, basically we have till around 9:30, 10 o'clock, then we will slowly shoo you out so we can tidy up and go home as well. So thank you everyone.